It's 5 GB. Okay. So we'll try with this resolution. And we'll see. PE files for Pocket PC. I will start with the tools you need. Then, or you can dump PE files because it's different from Windows PC process dumping. Then, how you can find entry point of the original application. I will also present anti-debugging techniques on Pocket PC. And I will also give 2 examples. One of them is UPX, which is a free packer for PE files, and then some commercial protector. I won't give the name of the protection system just in case. And then I will do demonstrations. So we have seen a few malwares on Pocket PC in the past, but none of them were actually compressed or encrypted. And since most of the Windows PC malwares are encrypted, it might happen in the future that we have compressed or protected malwares for Pocket PC or smartphones. Anyway, there are a few compressors and protectors out there for Pocket PC. You have event-free ones like UPX, so anyone can get UPX and compress their malwares. And UPX allows you to unpack the file, but you can easily patch the file so UPX doesn't uncompress it anymore. And there is nothing public regarding unpacking Pocket PC files, and there is no public dumpers to do it. So I'm going to give one after my talk. So the tools you need, you can use IDA Pocket PC debugger. For disassembling files, you can use IDA 2. There is no process dumper for now, and you can use file manipulation tools like NEP file editors, like LordPE, and hexadecimal editors. So, process dumping. The main problem when you want to dump Pocket PC is that there is no PE header in memory. So if you dump the application, you still don't have the PE header, and the file is not going to be loaded by the operating system. There is no public process dumper for Pocket PC. And you could write one, a native process dumper, but you don't need to do that. So how can you dump process on PC? You first use IDA debugger to find the original entry point. And then you can write an IDC script for dumping. Then you can, so the main problem is there is no headers in memory, so we can just use them from disk. And once we have the headers from disk, we can just append everything from memory to this header file. And then we need to fix the headers with things like we need to change the physical size to the virtual size and the physical offset to the size in memory for each section. And then you need to fix the import table for your files if you want it to be working or if you want to have a clean disassembly. Then the next point is finding the original point of the application. It's very similar to Windows PC. You can trace the whole application until you find the jump to the original entry point. You can use compiler signatures to find the entry point. This works very well because you don't need to bother with the anti-debugging tricks. You can just pass the memory when the application is being run, and you can quickly find the entry points using signatures. You can also use breakpoint on Windows on API functions, such as the ones used to load the imports, like get proc address, load library, or the ones used to flush the cache, like flush instruction cache or cache sync. Because in order to execute uncompressed code, the packer for Pocket PC needs to flush the cache, because if it doesn't flush the cache, it's going to execute compressed code or encrypted code. So usually they flush the cache just before jumping to the original entry point. So the anti-debugging techniques for Pocket PC, most tricks from Windows PC can be used to detect debugging. You can use timing execution to detect single stepping. You can use API functions to detect debuggers. There are a few functions inside core GLR. And you can use breakpoint detections and checksumming, things like this. But another very powerful technique is using the instruction cache to kill debuggers. Because as I said, Pocket PC use a ARM processor, and most of the time, and if you are trying to decrypt instructions before executing them, you need to flush the cache so you can actually execute this decrypted code. You will execute encrypted code otherwise. But one thing is debuggers will flush the cache for you anytime. So what you can do is you can just encrypt part of your loader with a random key or whatever. You can just modify parts of your code. And your packer is not going to flush the cache, so it's not going to be executed. But if someone is debugging this protection, then the debugger is going to flush the cache and you will end up calling garbage code. So this is a very nice feature of the Pocket PC processors. Unfortunately, there is no easy way to locate such anti-debugging tricks, because most of the time the loader is going to decrypt its own code anyway. So some of those packers have plenty of layers, so they will decrypt themselves a dozen times. And so they could just put an anti-debugging inside those layers. So you need to be careful when you are tracing every layers and trying to look for suspicious decryption or fake decryption. And once you have found this suspicious decrypting code or something that modifies the flow of the application, you can just skip it by changing the instruction pointer, the PC register, which is the same thing as the EI register for Intel processors. And then you can just keep tracing the loader. So a little example now, UPX. UPX now supports PE files for Pocket PC too. The way it works is very similar to Windows PC. The file is compressed on disk and it will self-decompress itself at runtime before jumping to the original entry point. On the other hand, the jump to the entry point is even easier to find because it's not encrypted. You will spot it right away. You can see there the PC register will get this value, and this is the address of the original entry point. So this is the start of a compressed file on Pocket PC. There is two main subfunctions. One will uncompress the application in memory, and it will also handle the import table of the application, because you need to resolve every functions before you can call them. And then you have another subfunction it's just going to flash the instruction cache so it can call the uncompressed code. So this is an important link part of UPX for Pocket PC. It's very similar to the Windows unpacking routine. It's just a few loops. It just does a load library on the GLLs it needs to load, and proc address on the API function it needs to call. So you can easily find out that this subfunction is doing import loading, because you will find calls to those Windows functions, and you will also find constant like the one used to check whether we are importing functions by ordinal or by name. So it's very similar to the Windows UPX. The only difference is the actual assembly language. And exactly like the one on Windows PC, you have a clean image section headers array of structures in memory, so you can have information about the sections prior to the compressing. So you have everything like the original section name, the original virtual address of the section, the original size of the section, the write access of the section, if you can be executable, writable, readable, etc. And so you have, this is the first section, the text section. You have the air data section, which is the import table stuff. So you have everything saved in memory. So if you want to dump this application, so you can reverse engineer it, the first thing you need to do is to pause the application on the entry point. So as I said, you have this instruction, which is basically loading this memory location inside the PC register, which is the EIP. And then you can just resume application with F9 inside your debugger. You will stop just before the jump. Then you can single step once more, so you are right at the entry point of the completely unpacked application in memory, and then you can dump it. I will give you a demonstration shortly. So now this other commercial protection, it compresses and encrypts your application. There is like 20 layers of encryption on itself first, and then it will decrypt the application. It has a lot of anti-debugging techniques, and it can also encrypt the resources, so you wouldn't find any strings if you use the string command or anything. Everything is encrypted, and it has many more features, like you can add licensing, like serial numbers to your binary, even if you don't have the source code. So this is the disassembly of this protection. It looks very similar to UPX. You have still the same thing, load library and get proc address. So this is very something you need to look at when you are trying to unpack application on Pocket PC, because most of the time they are going to use those functions.